Good afternoon, ladies and gentlemen. I am Vana Radu. I work as a program officer at SNS JU. I would like to welcome you all to the Info Day and Brokerage event of the SNS JU front-end module call for proposals of this year. This is an online event which has two parts, the Info Day and the second part, the Brokerage event. During the Info Day part, we will share information on the call context, orientations, content of the work program, and the call conditions. And at the end, we are going to have a short Q&A session. The brokerage session will see potential project participants who will make short pitches to promote their competences and or their project ideas. I'm going to give you a very quick overview on the practical details of the day. The event will be recorded. We are kindly requested to keep your microphone always muted unless you are presenting. All presentations of the day and recordings will be available on the main event webpage, and you can of course use the chat box to ask questions during the presentations. And the answer will be provided as soon as possible in the chat. And of course, you can raise your hand during the Q&A session at the end of the presentations. For a very brief overview of the agenda, the opening remarks will be given by Colin Wilcock, the 6JA Governing Board Chairman and the Chairman of the SNS JU Governing Board, followed by Thibaut Kleiner, Director of Future Networks at DG Connect of the European Commission and Vice Chairman of the SNS JU Governing Board, followed by our Executive Director, Erzsébet Fitori. Then we are going to go into the topic presentations given by Bernard Barani, Senior Consultant at 6JA, and followed by overview of the FEM call of the CHIPS JU and expected synergies given by Francisco Ignacio, Program Officer at CHIPS JU. My presentation on call conditions will conclude the presentations of the Info Day, and then we're going to have a 10-minute Q&A session. So without further ado, I will give the floor to Colin Wilcock. Colin, the floor is yours.
Super. Thank you very much for that introduction, and thank you everyone for taking time today to be at this meeting. Let me welcome you on behalf of the private side, 6JA, and also in terms of the SNS JU overall as chairman of that board. It's wonderful to see such participation and interest in this area. I'd like to stress that I see this as important, not just intrinsically from the area that we're going to discuss today, the front-end module, which clearly has its own importance and own relevance. But this is also important beyond that isolated area, in so much as we are trying to leverage the strength that we have within mobile communications in Europe. It's one of the few areas in ICT where we really have some of the key world companies within Europe. We have strong operators, we have strong research, we have an ecosystem of mobile communications all the way from GSM further. And what we need to do now, and we believe also in the future, is leverage that strength. And in many ways, this is an example of trying to take that strength we have in classical telecoms, classical mobile communications, and trying to leverage that, shall we say, in the microelectronics world. Beyond that, it is clearly also an issue for now and for the future of Europe, trying to link together different areas of expertise. So we currently have these different JUs, different instruments for funding, different partnerships, and we have some issues with trying to actually cooperate and get an overall system view, an overall system solution for Europe. So also in those terms, this is an important activity, trying to link two key areas of two building blocks for Europe in mobile communications and microelectronics. And there'll be obviously a lot more detail coming further. But especially now, when we're starting talking about the next multi-year framework, MFF, when we're talking about FP10 and the European Competitive Fund, it's really important that we show that such collaboration can work, that we can leverage our strong areas of ICT technology, our excellent research within Europe, and we can then come to an overall solution. We can have an end-to-end solution which actually then makes a difference in the marketplace. So I think this is a first step. I think this is really important, and I'm very much looking forward to this event today. And with that, I hand back to the moderator. Thank you.
Thank you very much, Colin. We are now giving the floor to Thibaut Kleiner.
Yes, good afternoon, and indeed also from my side, welcome to this Info Day and also to the Brokerage event for the Smart Networks and Services Joint Undertaking. I think that this call on the front-end module is really a very important development. Myself, I'm Thibaut Kleiner, I'm the Director in Future Networks at DG Connect in the European Commission, and I'm also the Vice Chair of the Board of the SNS JU. And today I'm really glad that we are starting really the work on this issue, because it's really the result of intense cooperation and discussion between the SNS JU on the one hand and the CHIPS JU on the other, to advance one of the main priorities for our research and innovation agenda. And this front-end module initiative at the European level is really based on groundwork. And I think that today we are officially opening the door for the best proposals. And I think our ambition is real we want to propel Europe forward in really establishing a sovereign advanced 6G infrastructure. And that requires also this element on semiconductors. Before we hear about the specifics of the call, I wanted just to emphasize a few elements. First, the rising importance of digital connectivity in our broader economy. So these days we hear a lot about software, cloud data, but all of this would not be possible without the critical physical infrastructure that bridges the gap between the digital network and the radio frequencies in our environment. So if we want really to remain at the forefront of digital connectivity, we must navigate a highly competitive global landscape, because our major trading partners and competitors have already given the highest strategic priority to advance telecom capabilities. Also in the EU, we want to make sure that microelectronics doesn't stop us. We want to make sure that, on the contrary, we can address critical vulnerabilities. We want to remain, to some extent, we cannot remain reliant on external supply chain. We need to do it also on our own. And that's why the front-end module is really critical as part of the telecoms infrastructure. So today we are placing this in the context of convergence of interest between telecoms and microelectronics, but we also want to make sure that there is synchronized alignment between the two critical sectors. That's something we worked on, and following the early Connect roadmap of 2021, we saw the delivery of a comprehensive FEM roadmap in 2024. And this was actually jointly endorsed by the 6G Industry Association and the Association for European Nanoelectronics Activity. So the roadmap really was something that was already worked out, and it outlined the complementarity and the synchronized research activities between SNS and the CHIPS JU over several years. So today I'm really happy that we managed to get so far. And I think that with the SNS call on the design of overarching system architecture for the 6G front-end module and the delivery of proofs of concept, we can really make a significant step forward. The dual approach establishes a clear practical way forward. And I wish really that today we can meet the targets, 50% energy savings in the transmission compared to existing 5G systems, elements that will be strategic for AI-driven made in Europe 6G network as well. So really from my end, I wish you an inspiring, productive session. And I hope that we can also broker in the day important partnerships between telecom, microelectronics to really form the consortium that we need for the future. Thank you for your attention.
Thank you very much, Thibault. We're now going to give the floor to Elizabeth Fittori.
Thank you very much. Good afternoon, and also a warm welcome on my behalf to the Info Day and Brokerage event of the SNS JU FEM 2026 Call for Proposals. Building on the welcoming words of both Colin and Thibault before me, I would like to first of all place this in a broader context of Europe's strategic objectives, one that is related to competitiveness and the importance of closing the innovation gap with our global competitors in advanced technologies, including microelectronics as well as advanced communications technologies. Next slide, please. It is also in the broader context of European economic security. Europe has set out the key areas of critical technology capabilities in a Commission recommendation, and indeed the key components are very closely linked to 6G components and subsystems, namely semiconductors, artificial intelligence, and advanced connectivity, three of the key elements of the call that we are opening today. If we move to the next slide, please. It is also important to note that this call for proposals sits within the broader project portfolio and program of SNS JU, where actually microelectronics has had an important role. It has been a lighthouse within our existing project portfolio so far. And then if we move to the next slide, please, I think it is also important to emphasize that the call comes at a crucial moment of global competition and geopolitical movements, and other regions also increase their strategic investments in telecom R&D, understanding the increasing convergence and increasing complexity with adjacent technology areas. So I'm very happy that so many of you are participating in this Info Day today, and I invite you to become part of this drive for building a European ecosystem, industrial and research ecosystem in radio access technologies, including microelectronics. The call that we are opening today also sits in a biannual work program of 2026 and 2027, with a 14 million euros budget dedicated from Horizon Europe. As you can see, the work program of 2026 has been intentionally a more focused and targeted work program on fewer topics, but strategically important topics, which is preparing for the last call for proposals of SNS JU under the current MFF that is planned to open in 2027. And if we move to the next slide, please, I also wanted to share with you four key strategic aspects, the rationale for having this FEM call with the view of securing European leadership and European competences in the front-end module microelectronics and also in the connectivity domain. First of all, competitiveness and sovereignty, securing a European supply chain in the domain of microelectronics for telecom as an important priority. FEM is a critical part of the radio access network, therefore having a European ecosystem addressing this component is absolutely key for both our competitiveness and sovereignty objectives. Secondly, we wanted to align much more closely with a path to exploitation via the CHIPS JU pilot lines. Therefore, this call is much more closely aligned, and you will hear from later presentations actually the delineation with the dedicated CHIPS JU call, as well as the foreseen collaboration. The third strategic rationale is related to developments, in particular from guidance from the Radio Spectrum Policy Group with regard to the upper 6 gigahertz band. And finally, a much stronger integration of AI and machine learning, taking into account the latest progress at 3GPP level, the applicability of AI and machine learning to the FEM, and in also reflecting on the role that has been assigned to SNS JU in the Apply AI strategy of the European Commission. So if we look at the call itself, it is open with, as I mentioned, 14 million euros of EU funding to secure European leadership in this domain. And the closing of the call is 3rd of September, and in the later presentations, you will hear all the details for the objectives and the desired outcomes of this call. Thank you very much for your attention, and wishing you a nice info day and brokerage. Thank you.
Thank you very much, Elizabeth. We are now giving the floor to the next speaker, Mr. Bernard Barani. Please, the floor is yours.
Many thanks for giving me the opportunity to present the call. So a few words on the, let's say, overall framework of the call. I believe we can say that it's not a business as usual call, in the sense that it is part of a larger initiative that spans over several calls, in particular one under SNS, one under the CHIPS JU, which is also open under the work program of CHIPS JU for 2026. And it is also in discussion to have a follow-up in the last part of the SNS work program 2027, but this is still to be defined and to be agreed between the members of the SNS JU. But the idea is to reflect the importance of the topic that was presented by all the previous speakers. So something which is large scale. So altogether, if all these calls are eventually implemented as planned, it will represent more than 100 million euros investments, both from the public side and from the private side. And it has a significant, let's say, potential impact. Of course, to materialize this impact is that one of the key conditions is that there is good complementarity and directionality over the various calls. That means that we are not implementing, let's say, calls completely independent of each other with completely different solutions. But we have behind this a set of calls that shoot in a common direction, with a strong European industry commitment, both from the telecom side and the microelectronic sides, towards a clear intention to lead towards implementation of the technology in eventual commercial systems or industrialized systems. So one of the, if you want, just have one sentence more. One of the, let's say, companion objectives is also to have an industrialization target. That means that to use this set of calls also to pave the way towards a new capabilities in microelectronics for telecoms, as it is, let's say, the intention of CHIPS Act, from what we understand, under also the condition that we support European sovereignty and competitiveness. So if you go to the next slide, voila. Here you have a sketch of the complementarity of the various calls. So what you can see is that the SNS call, primarily on the upper part, is designed to cover primarily the system aspects and some early technological aspects. The CHIPS JU call goes much more into the detailed technological aspects, the technology implementations, the real scale up of the technologies up to the possibility to bring the technology to fabrication lines using the chips JU pilot lines as a preferred, let's say, vehicle to lead into a pre-industrialization. And the last goal, which is at the very bottom of the slide, again, if it is materialized, if there is an agreement on that under our program 2027, would lead to, let's say, full integration of a FEM and over-the-air test, OTA demos, which are not directly planned in the previous calls. So this is the kind of split between the three calls. So if we move to the next slide, we can focus more on the SNS call, of course. And the SNS call, if you read the text, it talks about the challenges and objectives. So the challenges are categorized in to solve. The challenges to address are categorized in 4 blocks. The first one is to address the FR3 band, because it is a priority band for the actors, for industry, both from the operator side and from the vendor side, but it has also, let's say, the requirement to cover the upper 6 GHz band, which stops at 7 GHz, not at 7.125, which is already in the FR3 band. So the idea is to develop a front-end module that at the same time covers the upper 6 GHz band and the FR3 bands, but which takes also potentially into account regional variation. It's not obvious that all the ITU regions have all the same, let's say, allocations for the services. So the possibility to be flexible should be there. Also, sharing capabilities with incumbent services is a real challenge, because there are several, let's say, users of the band in this range, satellite in particular, but also military users. And versatile implementation across different IT regions is a potential challenge. Then at the technological side, there are plenty of issues which are kind of summarized here. It starts from the complexity itself of the RF front end, which has to lead towards a high integration level of antennas. I mean, to have a say, form factor which is more or less the same as a NEFR1 antenna, but with much higher level of integration of radiating arrays. The processing complexity is at least 1 order of magnitude higher. The integration of multiple technologies from baseband to RF and the packaging is a clear challenge. The applicability of AI/ML for specific functions, especially at layer 1's optimizations, is a challenge. Trade-offs between different technologies, and of course, cost and energy efficiency are always difficult drivers to meet the overall design. Then there are a number of challenges which are related to use cases, in particular the possibility to serve ISAC and at the same time communication taking into account the latest characteristics which has been defined at the level of standardization bodies such as 3GPP or ITU, where now we talk clearly about 400 megahertz channels and uplink emphasis, because AI/ML is supposed to create traffic on the uplink with much more, let's say, quantities of traffic compared to traditional type of traffics which have been, let's say, dominating the communication landscape so far. And at the end of the day, one of the key challenges is to, let's say, stimulate and promote the European industry, both from the perspective of the know-how in the overall, let's say, domain of this FEM, in terms of industrial capabilities at the level of the supply chain, trying to, let's say, create components which supports both the microelectronic sites and the telecom sites to lead towards capabilities in this domain in Europe. And this, all this is also very much dependent on how we can leverage the CHIPS EU pilot line to create these pre-industrialization capabilities that we intend to promote with the call. So the scope, this is basically what you find in the call text. So it's it's much more detailed in the call text, and you will find there. So the scope is clearly the coverage of the FR3 band with the upper 6 GHz band for the front-end module, taking into account potential ITU regional variations and incumbent users. The possibility to serve ISAC capabilities with maximization of functional blocks. That means to have the minimized complexity of implementation when you trade off the communication function and the sensing functions. The characterization of all the building blocks, of course, the FEM is composed of a huge number of building blocks, power amplifier, low noise blocks, beamformers, and you name them. So all these elements have to be characterized and lead to a design which is integrated from the RF, from the baseband to the RF, and also taking into account the IT requirements, bandwidth, channel width, and so on. Capability for uplink capacity is considered as one of the design drivers because of these new things of AI/ML traffic. Also in scope is the coverage of several use cases, either classical type of FR1 type of use cases in the cellular domain, of FR2 use cases like fixed wireless access, but also taking into account requirements from use cases from ISAC, for instance, such as subband full duplex operations, which is a new thing coming from latest release, late release from 3GPP, secure ISAC integration. Of course, in scope is the analysis and trade-off of technology. So there are a huge number of technologies which are potentially called upon to integrate a FEM. I mean, here there are a few which are mentioned, FDSOI, GAI, INP, CMOS, and so on, and their integration. But this should not be considered only from the perspective of the beauty of the technology, how far the technology is great to achieve the objective, but it should be also traded off vis-a-vis the EU ecosystem capabilities, how far the EU ecosystem capabilities can cover this technology or not, how far it is compatible with CHIPS EU pilot line transfer, and how far it, let's say, maximize the packaging feasibility, which is also, from what we understand, a weak side on the European side. Also in scope is AI/ML applicability for key layer 1 functions. So this is up to the proponents to look into this. For instance, channel state information, spectrum management, interference mitigation. There are a lot of functions which are potentially, let's say, likely to benefit from AI implementation, including non-functional properties such as energy efficiency. But we are not suggesting AI/ML implementation particular design because we believe this is very sensitive and this is potentially very much dependent on the let's say industrial strategies in the fields. And of course, in scope is the plans for transfer towards pilot lines. As we said, we like to use this CHIPS EU tool as much as possible to eventually lead towards the industrialization of a product, including, of course, tools and environments like EDA and PDKs. So in scope also, and this is the last slide of the scope, is proof of concept for critical subsystems. So here it is left to the appreciation of the proponents to define critical subsystems that are priorities within the budget call. Of course, the budget is limited, much more limited than the CHIPS JU budget altogether. So few proof of concepts can be identified at scope at TRL 4.5. And the key, what is said in the call, the key to realize the various objectives and part of the scope is that it has to reflect, the scope has to reflect a very solid combination of European industrial leaders in the radiocoms and microelectronics domain, with a demonstrated track record and capabilities to industrialize and market the solutions in Europe and at global levels. And the second key in terms of scopes is a contribution to the sovereignty of the EU supply chain in the domain of microelectronics for this particular domains. And it has a number of impacts in terms of FEM design, especially in terms of securing the technologies up to the prototyping level. Now, if in the scope, the proponents believe that they can only cover a subset of all the bullets which are under the scope, it's possible, it's allowed by the call, but this should be very specifically specified in the proposal. What are the bullets which are really at the heart of the proposal? So in terms of expected outcome, I will not expand too much on those. So you have one first of slide that really reflects the text that you have in the call, where you have different type of expected outcomes. Some are related to spectrum operations and mitigation of interference. Some are related with, let's say, overcoming the roadblocks for technology implementation, and some are related to use case, let's say, capabilities. Now, if you move to the next slide, there is another set of expected outcomes, voilà, which is a little bit more, I wouldn't say unusual, but it's a little more specific to this type of call, which is really to stimulate the European telecom microelectronics ecosystems to move towards heterogeneous integration of different technologies, which is something which remains a difficult domain at EU level, and to progress on advanced design tools, EDA, PDK, because we believe that these are companion type of subjects. It's difficult, it's potentially difficult to design technology at TRL 5 if you don't have EDA, PDK tools at TRL level 7 or 8. So the things are kind of related. They are kind of intertwined type of topics, even though it's not the topic of this call to develop design tools, but it should be seen as a companion type of activities. The industrialization pathway and the utilization or the leveraging of the capabilities of the CHIPS JU pilot line is something important. The bridging of the CHIPS JU ecosystem, of course, is important because we like to see the two environments really coming together and shooting in the same directions. And finally, an expected outcome is to support the Apply AI strategy, which is an important document of the Commission, which you may want to read, because AI activities should, in this type of activities, should fuel what the Commission expects in terms of Apply AI strategy outcomes. So again, as was said by already the previous speakers, this is aimed at supporting the European sovereignty and competitiveness and to really bridge.
Many thanks, Bernard, for your presentation.
Most welcome.
We will give the floor now to our colleague from CHIPS JU, Francisco Ignacio. Please, the floor is yours.
Okay, so good afternoon. Yeah, my name is Francisco Ignacio. I'm a program officer in CHIPS JU and Undertaking. First of all, thank you for the invitation to explain our call on the 6G front-end module and the relations that we are having that has been already explained with SNS Call and the other activities. Actually, we have been looking for collaborations with other joint undertakings and agencies in the last years. With more or less success, I have to say. For example, with the AHI JU and with Clean Hydrogen JU, we have some actions together. But definitely, we see that a lot of synergies between the activities of the SNS JU Undertaking and ours. And it would be very interesting to coming together in many aspects of our actions, as it was explained. From our side, our call is the 6G from the module is a focus topic call under the Horizon Europe program. And it's a good example of these synergies that we are having. You can find actually all the information I'm going to explain. You can find it already in the Appendix 7 of our work program, and you can download it from our website. And yeah, there are much more details of the call that I'm going to explain now in this presentation. The call is intended to be published on the 7th of July. It's not published yet, July of this year, and it will be closed on the 16th of September. The indicative JU budget is around 20 million euros. The national funding is still not totally clear or decided, but will be more or less in the same environment. And then the contribution of the consortium and the industry. So yeah, that would be the global budget for this action. Okay, on the context of the call is the same that you have been listening in the previous presentation, basically, because yeah, we are in the same line of collaboration and the synergies now that we were mentioning. They are related and they are looking between the collaboration between the two calls. The evolution of the communication technologies to the 6G due to the explosion of data and the future capacity demand requires that we invest a lot of substantial research and innovation on improving the technology for increasing the spectrum, going to the FR3 band, obtaining more efficiency and functionalities that will be needed in the 6G, like AI support or the ISAC that was being mentioned before. Therefore, enabling massive MIMO adaptive antenna systems, handling and storing increase of antenna elements is part of what we look in this call. Developing the corresponding front-end module is critical for allowing all this and maintaining the competitiveness of Europe as a strong contender as global supplier for the 5G and the future 6G networks. So the SNS call, that's why we have the two calls, the SNS call and the CHIPS call, and how they collaborate between them. The SNS call covers the design and the validation activities of the system requirements, describe the ones that I was describing before, addressing the use cases that dimension the front-end module radio design, and then the validation of building blocks and system integration. And that is when there is the link with ours, because in the SNS call would be the validation of the building blocks that are being developed or that can be developed in the CHIPS JU call. Our target is to develop the building blocks that compose the integrated front-end module with heterogeneous integration at subsystem level, that it will be later in the future completed with a system validation on the SNS call. Given these synergies, there should be an alignment to complement the work of both calls, and definitely a collaboration between both consortia is encouraged, and it should be visible in the proposal. The next slide. As I mentioned, the main outcome expected for the CHIPS JU call is the design and the definition of the specifications, as well as the implementation of the key microelectronics building blocks of the front-end module on the FR3 band. And that should be preparing the integration of the complete integrated front-end module system that are the activities to be developed in the SNS call. Well, for increasing the capacity of the 6G, there are several ways, no? Increasing the spectrum range, or increasing the efficiency of the spectrum use, or developing better technologies with more integration. So in the outcomes of our call go in these three directions. The expected outcomes of the building blocks should mean a progress over the state of the art to optimize the cost-performance trade-off for the required specification of the maximum data rate, spectral efficiency, energy consumption, spectrum sharing with the other uses of the FR3 subband. In direction of the efficiency, the expected outcomes, it should allow enable large arrays integration, high bandwidth for carrier aggregation, etc. No? And then for the part of the technologies, building up on core technologies and IP blocks for further package integration and baseline development for implementation of more critical functions and subsystem integration. Also, development of the characterized models for RF, standard cells for support for compute, interconnect, and memory, supported with the relevant PDKs that I will mention later. Those are the main expected outcomes, but there are much more, as I mentioned, more details in the redaction of the text of the call that I invite you to read to look for more details on all these expected outcomes. But it's important for preparation of the proposals and the project, it's important that it should be visible how the results contribute to reinforce the European ecosystems in microelectronic suppliers. It has been mentioned also previously that this is an important aspect of our calls. No? How the consortium will create the synergies with the SNS JU Call, and the possible, that's also very interesting to mention, the possible collaboration with the relevant pilot lines. In our pilot lines, we have several pilot lines that are with technologies related to the activities to be done in this call, FAMES, in Apex, even in Nano IC. So the collaboration with the pilot lines is interesting, and if it is visible in the proposal, I think it's positive. And then the next slide, the scope. Okay, here, yeah, you will find again more details in the call text, but the proposals submitted to this call, to our call, should address the front-end module technologies challenges that we are described there in the slide. For the transmitter and power amplification, high power with high efficiency, design efficient power amplifier architectures, and more. No? For very low noise and high dynamic range receivers, for filters, RF filter technologies, antenna filter co-designs, packaging integration, for transceiver phase shifters and data converters, heterogeneous integration of different functionalities that was mentioning also before, the different semiconductor technologies, gallium nitride, CMOS, FD-SOI, on sustainability, thermal optimization of chips modules, energy efficient designs. On the advanced antenna systems, advanced architecture antenna for scalable massive MIMO, also technology for ISAC, integrated system and communications, and multifunctional sensing hardware, and different applications for these technologies. So this should be, all of this should be more or less visible in the proposals that we expect for our call. For all these technologies, that was the IP blocks, there should be already defined in-house in the partners of the consortium, so they are already expected to be available from the consortium partners at a TRL level 3, more or less, with the expectative in this call, in the proposals, to put some effort in an investment in the integration of subsystem level, so going up to TRL 5 approximately. And this is regarding to the technologies and the building blocks, but with respect to the design and development environment, then it is expected that it should be compatible with this design at TRL level 5 for the technology. So it's expected at development tools like PDKs, expected more or less at TRL level 7 or 8, something like this. This is more or less the expectations, but you know, the TRL levels actually is the main part of the proposal, has to be centered in these levels, but obviously you can have activities before and after, so you complete the full proposal. Although the development of this initiative, our one is pre-competitive, it is always expected in our calls that the proposal have a clear perspective of eventual commercialization. We are in a very close to market joint undertaking. Our calls are the same way, so this one will not be an exception. We are very market oriented and commercialization oriented in our calls. So even if it is pre-competitive, it will be, the proposal should show that there is a eventual commercialization by the European industry, and to show the potential activities, application of the technologies that are being developed in the proposal and the use cases. The proposal should show also measurable objectives and exploitation plan. Again, for us, the exploitation plan, what they are going to do with the results is fundamental. So in this case, part of the results or the development in our chips call, it's to be integrated or used in the later call or in SNS call to be an integration at system level, but maybe other exploitation activities or maybe use of the use cases or the results can be done. So all this should be explained in the proposal submitted to us. They also have to explain, that's very important, how they will coordinate these activities with the SNS call to reach the final system integration validation that is expected at TRL level 7 or 8. So basically, that's all. We would like to see in our proposal not only the development of the technologies and the activities that we indicate in our call and we are expecting for our building blocks, but also how they are going to collaborate, the two consortia, the consortium that is in our call, and how they are going to use these results in the activities of the SNS JU Undertaking. But the rest of the conditions for our call is the normal Horizon Europe call conditions that we have. And if there is any specificity, for example, the percentage of funding or the eligibility criteria or something, you can read all this information in the text of the call that it will be published, but you can already take it in our website. And finally, I would like to invite you also, if you are thinking on proposals for this call, to get in contact with our industrial associations, because they can guide you in more definition of the scope of this call, help you in, I don't know, consortia building or orientation or how to participate in our calls. So it's always interesting to contact the industrial associations of the chips you're undertaking. And that's all. I hope it will be very fruitful and we will have very good activities and very good proposals. Thank you very much.
Many thanks, Francisco, for your kind presentation, for taking the time to come and present to our Info Day. So welcome again from my part to the last presentation of the Info Day. This will be focused on the call overview and call conditions, so it will add a different aspect to the previous presentations of the day. This presentation is scheduled into 3 major blocks: the call overview, the general conditions, and the specific conditions, which are the SNS JU conditions specific to admissibility, ICOP, eligibility, SME, and we will close with the link to, of course, the second part of the day, which is the brokerage. So in the call overview, as mentioned before by our executive director, the call opened today, the 26th of May, and it will be closed on the 3rd of September. For practical reasons, you're invited to not wait until the deadline so that you can take full advantage of the technical aspects and submit smoothly. We list here for you a number of must-reads, and we listed the links for the EU Funding and Tenders portal, and of course to our R&I work program of the year, with a specific reference to the Appendix 1, which has a very detailed overview of the calls and the general call conditions. Of course, equally important is another background on the general annexes of the Horizon Europe call conditions, the list of participating countries, and the SNS JU specific provisions covering admissibility, ICOP, eligibility, and SMEs. We also put here for your information the frequently asked questions and support for call 7, which is under our website. And in case you have any specific other questions, which by any chance are not listed there, would you please contact us via email, and we will get back to you as soon as possible. The call conditions are set in the general annexes for Horizon Europe call conditions 2026-2027. For the full list of participating countries, including the latest updates, we refer you to the link which is in the middle box of the left side of your screen. And we are going to take you one at a time through the SNS specific conditions on the application format, the eligibility, including restrictions, the ICOP, the SME participation, and cooperations between projects. So as regards the general Annex A on requirements, of course, we welcome to have a readable, accessible, and printable application. We are very keen that all forms and mandatory annexes are included, that there is a mandatory plan for the exploitation and dissemination of results. And of course, there is a communication activity plan included. The page limit derogation is 70 pages maximum for proposals which follow the RIA model, which is basically the proposals under Stream B. And of course, there are a couple of aspects which are important in that proposals which are missing mandatory annexes for their participants can be declared inadmissible, and the coordinator must compile all the required declarations into a single document and submit it together with the proposal. As regards the ICOP, which stands for In-Kind Contributions to Operational Activities, there is, of course, the legal basis, which is listed in the Single Basic Act, in that the in-kind contributions to operational activity means contributions by private members, constituent entities, or affiliated entities of either, by international organizations and by contributing partners, consisting of all the eligible costs incurred by them in implementing indirect actions, less the contribution of the joint undertaking and of the participating states of the joint undertaking to this cost. So there are a couple of natural questions. What is the purpose? Well, the purpose of the ICOP is to stimulate private investment in addition to public funding as required by the JU implementation model. Who generates the ICOP? It is only entities belonging to the member other than the union signatory to the JU, which is the 6G Smart Networks and Services Industry Association, also known as 6GIA in short. How is ICOP generated? Well, it is by private entities belonging to the 6GIA that naturally generate ICOP due to the reduced funding rate, 90% for RIAs. Furthermore, in this particular call, the indicative ICOP level as percentage of the project budget to reach the objective is set at 3.6%, and this is included in the call text. The minimum ICOP at the program level for the project is at 0.5 million. In practice, we have a number of high-level definition on how the ICOP works in the evaluation. So ICOP is a specific impact subcriterion in the RIA topics. It affects the scoring. It doesn't affect the eligibility. Of course, also behind the scenes, when proposals are equally ranked, there is a tie-breaking mechanism, which in this case for the RIA, they follow a certain order. And it starts with the coverage criterion, then it moves to excellence, then it moves to impact, to the SME participation, to the ICOP level, then it can move to gender balance, and then it can move to other factors, as described in the vademecum. There is an ICOP declaration form. So the applicants must complete this ICOP declaration table in the application form, part B, and this is mandatory. And we will have a special slide coming up next to show you precisely how this looks. And this is how it looks in table 3.1K. And even if the ICOP is 0, this has to be filled in for each participant within a project, within a proposal. So for our topic, for our call, this table is considered for the assessment. Further Further on, we have information with regards to eligibility. The eligibility criteria under Article 22.5 was applied for the first time in the calls of 2025, and they also continue in this call. So there is a legal aspect, a legal establishment, and paragraph 1 says that for actions related to union strategic assets, interests, autonomy, or security, the work program may provide that participation can be limited to legal entities established only in member states or in specific associated or third countries. As regards to the ownership and control, paragraph 2 mentions that for duly justified and exceptional reasons, to guarantee protection of the Union and the member states' strategic interests, the work program may exclude or impose conditions on legal entities of the Union or associated countries that are directly or indirectly controlled by non-associated third countries. From a practical perspective, in order to achieve the expected outcomes and to safeguard the Union's strategic assets, interests, autonomy, and security, it is important to avoid a situation of technological dependency on a non-EU source. In a global context that requires the EU to take action to build on its strength and to carefully assess and address any strategic weakness, vulnerability, and high-risk dependency that can put at risk the attainment of its ambitions. And further on, in accordance with the General Annex B, there are other details with regards to high-risk suppliers. So therefore, entities that are assessed as high-risk suppliers for mobile network communication equipment within the meaning of restrictions for the protection of European communication networks are not eligible to participate as beneficiaries, affiliated entities, and associated partners. Furthermore, entities assessed as high-risk suppliers are currently set in the related Commission communication on the implementation of the 5G security toolbox of 2023. As regards to the eligible countries for this particular call, we list the member states, the associated countries, OECD, and Mercosur countries. And entities directly or indirectly controlled by a non-eligible country or by non-eligible country entity may not participate in the action unless it can be demonstrated by means of guarantees positively assessed by their eligible country of establishment, insofar this is a member state or associated country, that their participation to the action would not negatively impact the Union's strategic assets, interests, autonomy, and security. Of course, entities assessed as high-risk suppliers for mobile network communication equipment cannot submit guarantees. As regards to the implementation aspects of restriction on participation, all participants complete the ownership control declaration. The coordinator has to compile all declarations. There is a next step, which, as I mentioned, was the ownership control assessment, and the fourth step is the guarantees where applicable. The guarantees, of course, must be signed by the participants, and they will be requested and assessed by our services and the national authority services during the grant preparation phase. For more information on restricted calls, you have a link for the EU grants guidance document, and you also have the 2 templates as of this year on the ownership control declaration template and the ownership control guarantee. As regards to the eligibility and the minimum participation of the 6G IA, the strategic rationale is intended to support the ICOP generation with long-term commitment of the partners and the JU members, including in this specific case microelectronic sector players. The activities, as mentioned before, by the speakers of the day will also support the objectives related to the CHIPS Act, the IPCI on microelectronics and telecommunications, and target cooperation between SNS JU and CHIPS JU towards a common goal on microelectronics for 6G. As regards the compliance requirements, all applicants must fill the mandatory compliance table at the proposal stage in the application form Part B. And if this is not completed, then the proposal can be declared ineligible and it will not be de facto evaluated. As regards to the small and medium enterprises, we follow the program target level similar to previous SNS calls, which is 20%. And as I mentioned before, this will factor in, if that will be the situation, within the tie breaking in the evaluation ranking stage, should two proposals, the RIA proposals, be equally ranked and cannot be separating using the previous criterion, which were the coverage, excellence, and impact. There are also other conditions, and here we mentioned two of them, which are the project collaboration agreement. So therefore, in other words, meaning that the participants of the selected project will be requested to cooperate in the SNS JU program for topics of common interest by signing what is called a collaboration agreement. And further to the open science provisions, we mentioned that AI ML training datasets created and used in StreamB projects must be made available through a common repository and accessible and reusable by other SNS projects across the program lifecycle. Last but not least, we have a slide with links in the support and brokerage platform. And here we also mentioned the funding and tender portal, the research inquiry services, the links to the national contact points, to our own brokerage platforms, and of course for newcomers in EU grants. With this, I will open the floor for the Q&A session. And thank you very much for your attention. I can see in the meantime that my colleagues have replied to many of the questions in the chat of the WebEx. I was not able to do so as I was presenting myself. If there are any questions of the participants that have not been answered so far, would you please like to raise your hand? There are no questions? No. Professor Ozdan, please go ahead.
Dear Ona, thank you very much for your presentation. I just want to ask that we haven't just applied for a national bursary product or something like that. Is it possible for us to go with you about our project proposal?
I couldn't hear clearly. Could you please repeat the question a bit slower?
Okay, we didn't apply for anything for national project bursaries or fund. Is it possible for us to apply with you for the international one? Because as far as I read from the chat, it is possible, I guess.
If you are eligible to participate, you can participate in the EU project. That is not a problem. Yeah.
Should we find a third country?
Each proposal have to have three different EU member states. That is
Thank you very much.
If we do not have any further questions, it is now time to start the brokerage event. I will, in my capacity as call coordinator, I will moderate the brokerage event. And as always, I will give you some practical details with regards to the second part of our day. So the event will be recorded. We are kindly asking you to keep your microphone always muted in case you're not presenting. Please note that all presentations and recordings will become available. We have dedicated 5 minutes per presenter. Of course, each presenter will share their own slides, and you will receive from our end a 1-minute warning to all speakers. You are welcome as an audience to use the chat box to ask questions during these presentations, and the answers may be provided directly in the chat by the respective presenters. In this particular section of the day, we do not have a live Q&A session. So what is the Brokerage platform? The Brokerage platform, it's a venue where idea owners and proposal leaders submit and share ideas. They can post project ideas to prospective partners who can then join to ask you, informing a consortium. It offers the modality for expertise. So if participants are looking for projects, you can post your profile, you can indicate your interest so that the prospective partners can find you. It is always a way as a link to browse submitted ideas to see if there is anything that you would like to offer your participation to. And it is a way also to browse submitted expertise offerings, that is to browse and search up loaded profiles to find the competences needed in your proposals. In today's brokerage, we have 7 confirmed presenters. So the first one to take the floor after me will be Balázs Yilmaz from the family medicine team at the Izmir University of Economics. I will give you the floor for 5 minutes. Thank you very much.
Okay, good afternoon, everyone. I'm Barlas Efe Yilmaz, a medical doctor at Izmir University of Economics in Turkey. I am also representing the family medicine department in my institute. So let's get into it. We are not engineers, we are doctors, and we bring what most strong front-end module teams lack, a real medical team that only 6G can solve and a doctor network to test it. We want to join your FEM consortium as the clinical section of the. Next slide. As I said, we are the family medicine team at Izmir University of Economics. We bring 3 things: a survey on point of care ultrasounds, already approved by our ethics committee, deep knowledge of how doctors work in clinics, villages, and ambulances, as we do ourselves as well, and family doctors ready to be your end users. So what is point of care ultrasound? I want to mention that quickly. POCUS is question-driven ultrasound performed by a trained physician at a patient's bedside in a clinic or an ambulance or anywhere, I guess. Unlike conventional ultrasound, which is usually a full diagnostic scan, which usually is performed in an imaging clinic, POCUS is targeted. The clinician scans to answer specific clinical question in real time, such as, is there free fluid where I'm looking at right now, or is there a viable pregnancy, and so on. Like I said, POCUS, point of care ultrasound, is a targeted ultrasound instead of a full scan. So we test for if a patient's fluid intake is low, we can just point the probe at the patient's abdomen and check for the vena cava, which is the largest vein in the body, and check for the collapse and etc. So we can check for almost everything. But I trust my own skills on ultrasound, and I actually have a personal portable butterfly myself. I strongly believe that it can surpass and even make stethoscope a thing of the past entirely. So why does this matter for a 6G call? Family doctors across Europe could use this every day, and they don't. Training is uneven. Equipment rarely reaches small clinics. Doctors hesitate without a remote expert because they don't trust their own skills. And most important for this room, today's equipment, let it be a portable one or a full-on heavy big machine, cannot reliably stream live ultrasound from a rural clinic back to an expert. That last barrier is the one only engineers can solve, and that is what this call is built for. So next slide, please. Yes, thank you. We bring real assets, not a wish list, a web-based survey on POCUS answered by physicians from all over the world to determine the needs and gaps for POCUS and results thus far already shows there are a lot of gaps. A reachable network of family doctors for gathering needs and for running pilot sites in real primary care clinics where 6G devices can be tested under real physicians. So next slide, please. Thank you. We propose a clinical work package with 5 short tasks. 1, a cross-country survey on ultrasound use and connectivity barriers. 2, a use case catalog turning clinical scenarios into measurable connectivity and reliability targets. 3, pilot protocol design and ethics paperwork for field testing. 4, testing how doctors accept and use the technology day to day. 5, policy and training advice. So what we build together reaches primary care in almost everywhere, hopefully. To be clear, we are not here to lead or propose to lead the hardware. We want to close the gap between radio frequency performance and real clinical impact. The gap is where strong technical proposals lose points. So next slide, please. Last slide. So who are we looking for? An FEM coordinator, a university or research organization to lead, RF hardware industry partners, a portable ultrasound maker, a telemedicine platform, a 6G test network, and other clinical sites to join us in a Europe-wide study. If any of this resonates with you, please do not hesitate to contact us. Our contact details are on screen. Thank you. We are so hopeful to build this with you. Thank you.
Thank you so much for your presentation. We're going to stop sharing the screen now, and we will give the floor to our second presenter, Theodoros Kaifas, from the Department of Electrical and Computer Engineering at Demokritos University. Please, the floor is yours, if you can present your presentation.
Okay, thank you very much. So I will share my screen. Screen share. Okay. So I hope you are seeing my screen.
Yes.
Okay, I'm Theodoros Kaifas, and together with Professor Kyriakou, we are from the Microwave Laboratory, Telecommunications and Space Sector, from the Department of Electrical and Computer Engineering, Demokritos University of Thrace. And the talk entitled Modular FR3 RF Front-End Testbed. Let us see the outline of the small talk. Some sentences about the vision and the scope of the FEM initiative, who we are, the Microwave Laboratory, and our proposal. So about the FEM's vision, indeed we need to develop a RF module for FR3, 6G, a lot of enabling activities and challenges. So we're indeed should focus on FR3 because there's higher capacity than FR1, better coverage than FR2, suitability for cellular, for fixed wireless access, sensing and radar integration. So yes, FR3 is the hotspot of the challenge today. So technological challenges, higher processing complexity, integration, 1,000 antenna elements, a lot of TXRX change, heterogeneous integration, and all of those should be integrated in a system in a package. So a lot of priorities transfer towards pilot lines. So indeed we have to de-risk in order to enhance the potential of the Europe in those technologies. So what are we expect to cover? FR3, the half of the FR3, 7 to 15 gigahertz, 200 megahertz channels. The testing should be in a controlled tablet environment. We should address 2 designs, as we saw here. Massive MIMO, a lot of antenna elements. The key that is very important, we should use existing 5G sites for the 6G development. This is a key idea. The chipset should be multifunctional, digital to analog and analog to digital converters, beamforming ICs, analog front ends. So yes. Okay. So who we are? We are the Democratic University of Thrace. Is one of the biggest universities in Greece. We are here in the upper northern part of the Greece. We have a lot of campuses, polycentric multi-campus setup, 30,000 students, 10 schools, 30 specialized departments, staff around 700 teaching and researchers. And about the Department of Electrical and Computer Engineering, this is at the town of Xanthi. We have a lot of laboratories. We are from the telecommunications and space sector, but we have electronics and information technology systems laboratories, electrical energy laboratories. The list is over here. And of course, we have relevant facilities and expertise, AI and robotics. We have a clean room, prototype fabrication, sensor and microelectronics experimentation. Also VLSI facilities, IC and mixed signal design, FPGA hardware prototyping. And our base is the Macros Laboratory. According to the law, the Greek law, the Macros Laboratory focuses on microwave theory, waveguides, antennas, microwave applications, elements, electronic optics, and their applications. So this is some contact details, and Professor Kyriakou is the director of the lab. The facilities and the measurement equipment. We have spectrum analyzers, VNAs, up to 40, 50 gigahertz, anechoic chamber. We have portable devices like the field fox of the Keysight, up to 44 gigahertz. We can have IQ streams demodulated by of 4 and 5G. A probe station. We have we own we own cars in order to perform measurement campaigns, engravers, and various USRP devices. So we focus on FR3. We design antennas. For example, those are direct radiating antennas for direct-to-device initiatives. Also, we design antennas and beamformers. Here are Vivaldi antennas. This is a beamformer. Design and measure and construct and measure. For example, here we can see a system that scans the beam. This is a sweep beam system. Those two are two direction of arrival systems, are two different designs. And here we have two adaptive systems, one for radiation and the other for receiving. Okay, also a power amplifier. We can see here a design. There are various stages of this power amplifier. We can also make a lot of studies and have developed a lot of in-house software, not commercial software, our software, about edge value analysis, numerical results for curved rectangular waveguides, periodic structures, and characteristic modes. Again, I want to emphasize that those are in-house software, non-commercial. They are verified with commercial software, but they are in-house codes. And our proposal. So we have the project vision is is diverse, the range is extreme. So there is a lot of things in the technology stack that should be brought all together. Also, the main technical pillars, broadband array front-end design, analog hybrid reforming, antenna array integration, also wideband analog to digital, digital to analog investigation. All those things should be brought together and we should find a way to assess how those should work together, should integrate together, should function, and we believe that the only thing that can allow this to happen is to design and focus on a modular FR3 RF front-end testbed. This is our proposal. This is our main idea.
And for your presentation.
Okay, this is the last slide. So we are open to, although we are forming the alliance, we are welcome discussions for industrial partners, organizations, semiconductor ecosystem stakeholders. Those are the areas of collaboration. I'm Theodoros Kaifas, and the project manager should be Georgios Kyriakou. So thank you very much for your attention. Thank you.
Thank you. We are now going to give the floor to Christos Mourelatos from Stellar from SNS Technology. Please, the floor is yours. Can you share your presentation?
Thank you. Yes. Okay, can you see it in full screen?
Yes, we can.
Great. So, hello, I'm Mourelatos Christos, co-founder of Stellar Phronesis. Now, an introduction about our company. I don't know, you can see the next slide, correct?
Yes.
Thank you. So, we are a Greek-based company founded a year ago. We are and is a big Greece incubator right now. Our technology focuses on photonic processor design for antenna systems. We are in Thessaloniki, this is northern Greece, and our main target is to enable the future of scalable intelligent wireless systems. So the core competencies of our team is antenna and antenna array design, multi-beam beamformers, focusing of course on photonics, fiber wireless systems, and of course the software that will control this kind of processors. Dr. Onis Maximidis is the brain, let's say, behind this technology. He has at least 5 years of antenna development, antenna designing, and 5 years also in his postdoc for photonic processor designing. Now, what we're trying to do is to elevate the processing power of the antennas. We know that electronics have some limitations, especially when frequencies are higher, and elements, of course, are higher in the antenna. That's why there is this photonic integrated processor architecture. We have Ronis has already written a patent, and one more is coming until the end of the year. Our in-house software, which is an adaptive processing software for the control of the processor, allows us to have a real-time environmental correction. So here you can see a basic design and our basic logic of how this is going to be used. Okay, so either for transmitting or receiving, the photonic integrated processor will analyze the RF system, and then after the adaptive control, it can communicate with the digital processing. Of course, our purpose is to have a high throughput and low power wireless systems. Photonics can be pretty small, and of course, the power consumption also can be very low. And this is something that ESA has already validated, at least at their targets. Now, especially for the FEM call, the stream B, our expected outcome for a project should be to have up to 24 gigahertz. Of course, a large number of antenna with an increase in RF processing. Photonics and our design systems can have a low cost, low energy implementation and can be included in already design electronic design. And of course, you can have a uplink capacity, carrier rate. We can, if you are interested in this, you can discuss further with Ronis, of course, who knows better the technology. So you can find here some connections that we can have. We can have a communication about this. We will happy to hear from you.
Thank you very much for your presentation. We now give the floor to Janet Sedlev from the Internet Institute. Please, the floor is yours.
Hello, good afternoon from Slovenia. I hope you can hear me. So my name is Jan Sterle and I'm presenting Internet Institute, deep tech SME based in Ljubljana, Slovenia. So in the next few minutes, I would like to present how can we complement, let's say, the FEM consortia with our agentic AI layer for autonomous network operations and with our Beyond 5G platform for future FEM validation. But let me first start with a bit of our background. So this slide actually summarizes what we do from our product portfolio to established partnership and European R&D track record. And finally, our Beyond 5G platform, which is monitored and controlled by the AI, as I mentioned. So our portfolio includes industrial 5G and 6G test automation, observability suite that we complement with an open source broadened measurement platform prepared with the Slovenian regulator. And of course, we operate these solutions over the in-house developed industrial IoT system. We are actually active in multiple European projects, including SNS JU projects such as CS Green and Exigence. In June this year, we are starting a new European 6G project, which is targeting agentic AI for the 6G systems. And of course, finally, we are, of course, also a proud member of the 6G SNS Industrial Association. That's why we are actually here today. So our mobile one is our fully containerized 5G standalone private network running on Kubernetes Cloud. So why it matters for the FEM is that it already provides a complete modular cloud-native operational environment for realistic validation and integration. So two capabilities are actually especially relevant, let's say, for the FEM. First one is this network automation and digital twin functionality. And the second one is this energy-aware operations, which we developed through our SNS JU projects, which actually allows us to correct, let's say, FEM level energy telemetry with end-to-end network performance. In other words, we can bridge, let's say, the gap between RF innovation and operational deployments. So the centerpiece of today's speech, of course, is our Qmon Sensei, which is our agentic AI framework for autonomous 5G and 6G management. So the FEM Stream B call actually targets external AI support for this CSI or spectrum prediction, interference mitigation, energy optimization. And this is exactly the role of our Qmon Sensei and how, let's say, why we actually designed it. So to be clear, so we are not building the FEM chips. Basically, we provide the network side AI layer, let's say, around these chips. So Qmon Sensei is our multi-agent and LLM-driven platform. It uses the MCP servers and specialized agents to interact with the RAN, core, and edge, let's say, applications, and of course, all of these components. So the platform provides end-to-end network and UI visibility, cross-layer correlation, and automated root cause analysis. You can do intent-driven operation, of course, with using your natural language commands. So today we operate it at autonomy level 4. And of course, we have, let's say, clear targets with future this SNS JU development to achieve level 5 autonomy. So for FEM consortia, this means that our agentic AI platform can connect between, let's say, FEM telemetry and control interfaces and close the loop between the hardware level optimization and network level, let's say, operational impact. So we came to my last slide, just to summarize. So we are looking to join the FEM consortia as a technology provider. We can bring actually 3 complementary roles. First one is this network side agentic AI layer for integrating with FEM control and telemetry. The second is this operational use case experience from critical infrastructure, industrial IoT ports, and tactical 5G environments. And the last one is this operational validation environment, primary probably for the future FR3 FEM over-the-air testing phases. So if anything of this which I mentioned, let's say, fills the gap in your FEM consortium, we would be very happy to continue the discussion offline, of course. We are also next week at the EOCNC event in Malaga. Please find me, let's say, at Exigence booth so we can discuss openly for these open opportunities in person. So thank you very much for this.
Many thanks for your presentation. We now give the floor to Eric Galel from IRTBcom.
Hello everyone. Yes, it will work. Yeah. So hello everyone, I'm Eric Galel. I'm the head of few projects in BCom to build and to supervise projects. First, I will introduce. I can. Okay. A few words about ERT BCom. So ERT BCom is a technological research institute based in Rennes, in France, and we are specialized in the next generation digital technologies for decarbonation, and we have a techno provider for to boost technology and competitiveness while mitigating the risk associated in innovation. One word to say that is we are considered as an SME for the European Commission, even if we have a research institute. So some figures, I will skip it, we can see later on. So just a word to focus on our expertise on our contribution on European projects. In terms of expertise, we are working on networks and connectivity, images and vision, AI and data, MLOps and cloud, engineering and embedded systems, and digital and society for SSH. So all of those expertise target verticals as industry, logistics, cybersecurity, space, health, and XR VR activities. So thanks to this expertise, we could contribute to many European projects. As we can see the logo on the right side of the slide. And the last one is mainly related to sustained CG, focusing on 6G sustainable activities. And we were working also on 5G, 6G, and also the cloud with EDINAF project, which is a Fed programs. So now, if you focus according to the scope of this course, if we focus now on what we are doing in telecom advanced connectivities related to the frame course. So this slide here is showing the complete picture of our activities related to advanced connectivity. So we can see that they cover the full chain of the R&D, starting from TRL, low TRL to high TRL. So it means that at the beginning, we can work on the architecture and system engineering, how we are following the 3G, GBP roadmap, and we can make some specification study and so on. Then we can also work on the research and innovation, mainly focusing on BIMO, full duplex beamforming, and we are also working on the new waveforms and the ISAC as well on the free security. Then we can increase the TRL value with focusing on the modeling and simulation, where so we have some tools from Siona and also Omnet on MATLAB. Then also we have a platform, we can develop platform. I will have slides dedicated for that after that. So we have a dedicated platform focusing on we are developing the DU or the RU of the ORAN systems. And we are also working on the FPGA acceleration to have the high throughput LDPC decoders, for instance, and low-fi layers. And then at the end, we are also able to make some integration or deployment of the any application for the end-to-end testing. With the we have device, we have the RAN, the core, and the application, and we have a team dedicated for such integration and deployment. Now, if we focus more now again on the topics of interest for BICOM, so we can see here, we can see here the topics I want, so I don't have time to focus on all of them. Maybe this one, I'm just focusing on this one for the new waveforms, which is more related to the call here. So we can make some study of new waveforms in the context of ISAC, and we have also the waveform analysis and detection through AI. So this is the topics we are more targeting here in terms of contributions. And then also, if we take a higher level of the view, we have also a complete platform for the real. This is first one in France can have such platforms with the core network at the beginning. Any core network can be integrated in the RAN. We have a CU, DU, and RU. DU and RU are developing BICOM to perform such activities, or it's open to any kind of features, any kind of algorithms to be testing and to be analyzing in the real environment on the real platform. So these systems here can be proposed to any partners or any consortiums who would like to move. So thanks for that. It was very quick, but anyway. So I will be also at UCNC next week. And of course, if needed, we can discuss offline to continue the technical discussion and to move forward on any consortiums. Thank you.
Many thanks for your presentation. We now give the floor to Antonios Lalas from CERT IT. Can you please share your screen and try to complete your presentation within 5 minutes? Thank you.
Thank you. So this is a brief presentation about CERT ITI competencies in AI-powered 5G and 6G networks. My name is Antonios Lalas, a postdoc researcher in CERT. CERT is the largest organization in Greece. It's top 20 EU institutions in Europe. Information Technology Institute is an institute within CERT focused on telecommunications. It's first in Greece in the last 7 years. This is some of our technologies: artificial intelligence, visual computing analytics, of course, 5G, 6G, cybersecurity, and other domains. Some of our infrastructure, we have an autonomous vehicles, an additive manufacturing unit, and a whole smart home with different technologies. This is some views of the smart home. This is our 5G testbed. This is our RAISE, reconfigurable intelligence surface that serves as a base for AI-based anti-jamming and spoofing technologies developed in the NATCOR project, and also human activity recognition developed in the AutoTrust project. This is our autonomous vehicle that we use as a teleoperation use case over 5G. This is our anti-drone facility, built also under the Swarm Catcher, the first OpenCall of IDAL project. It's an anti-drone solution over 5G. These are of some of our projects. Basically, we coordinate the network project, the Autotrust project, and the Cognos project, and participate in others. Some of our expertise in cybersecurity, I will go through quite quickly. Maybe intrusion detection system, attack generation, penetration testing, V2X enablers, multi-physics simulations, also with MEMS, electrothermal actuators, and other kind of actuators and multi-physics analysis. Design based on computational electromagnetics, wireless power systems, metamaterials, and metasurfaces. Reconfigurable intelligent surfaces as well for energy harvest and wireless power. Different applications, anti-jamming and anti-spoofing. We participated in the Deep Sense 6G Challenge. We got the 5th position, and this is our research interest. We can summarize that we provide, let's say, apart from cybersecurity expertise, we provide also neuromorphic computing, photonic integrated circuits, reconfigurable intelligent surfaces, and ISAC integrated sensing and communication applications and use cases, AI-powered anti-jamming, multi-physics simulation of meta and design, and other kind of electromagnetic design as well. So for this call, we bring expertise and on designing integrated communication and sensing applications, also digital all RF level, radio development for advanced networks, including 6G RAN architectures and massive MIMO, evaluation of use of ML and AI for TXRX for 6G performance, analog neural networks, for example, neuromorphic computing, minimization of interference through the anti-jamming technologies we have developed, large-scale datasets and training sequences from our open repositories, optimization of energy consumption, AI-powered and LLMs-based multi-agent systems, data security and privacy, cybersecurity frameworks, intrusion detection and post-quantum cryptography, and also physical layer security, experimental infrastructures, recent anti-jamming already mentioned, 6G application and use cases, and of course, trial facilities, anti-drone, anti-jamming, autonomous vehicles, cyber engine simulation environment. So we're open for collaboration. Please reach out to me. Thank you very much.
Many thanks for your presentation. We now give the floor to our last speaker, Irena de Gruyter from WUPATEC. Could you please share your screen?
Hello, everyone from France. My name is Irene from WUPATEC. We are a French startup specialized in RF and digital front-end design for next-generation wireless systems. We're here today because we're actively building a consortium for this Stream B02, and we are looking for the right partners to join. So to give you a quick picture of who we are, WUPATEC was founded in 2016. We are based in Limoges and Toulouse, and we're a team of 11 highly specialized engineers. Our expertise sits at the intersection of RF hardware and digital signal processing, from sub-6 gigahertz all the way up to millimeter wave. So we serve 3 strategic markets: telecoms, including private and public 5G, 6G networks, defense, and space, new space, NTN. So our core competencies include Doherty wideband power amplifier design in MMIC and PAM development, power amplifier module. And then for the digital side, there's the FPGA and RF firmware that we develop. And we also have 5 patents in envelope tracking. We are a small company, but technically a very dense one. So what makes us relevant to this call specifically is what we have already built. We have developed the WFC Z25A, which is pretty much a high-performance 6G FR3 front-end module that covers from 10 megahertz to 25.8 gigahertz. It has 1.2 gigahertz of instantaneous bandwidth, and this is not a concept; it's a real product available today, and designed as a frequency extension for vector signal transceivers. So on top of that, we have assembled with this solution a complete RFSOC FR3 test solution, combining the extension board that I have just shown you with the AMD ZZU 670 platform. It is an RF SoC with our own firmware. And with this setup, we deliver real-time digital predistortion, signal generation, and full setup control. So this gives a validated end-to-end hardware and software environment for evaluation in the 7 to 24 gigahertz range. So it's precisely the FR3 band targeted by this call. So in short, we bring the front-end hardware and test environment, and we are already ready to contribute from day one. What are we looking for? So since this call requires a complete front-end module solutions that integrates digital, RF, and packaging technologies, we have the RF front-end, and this is what we need around us. So first, foundry and advanced packaging partners to co-integrate our RF analog and digital dies into a compact manufacturable module. And second, AI machine learning experts for the digital front end, specifically for the digital front end capable of managing from 200 to 400 megahertz channels, and also enabling AI for low power management and CSI optimization. Third, we need antenna array and beamforming designers for massive MIMO implementation. Fourth, the coexistence and sensing specialist, because there's a mandatory implementation of subband, full duplex, and ISAC in 6G. So this is why we need expertise in radar and sensing algorithms. Fifth, the RTOs, so the research and technology organizations to handle the low TRL modeling, thermal analysis, and hardware characterization. And finally, we need the industrial end users. So the operators or the infrastructure vendors who can validate the whole work in a real cellular fixed wireless access scenario, for instance, providing the concept of 5G cell site reuse with 6G frontends. So if your organization fits any of these profiles, we're ready to open a conversation. And then to give you an idea of where Wupatec is located inside French ecosystem, we are an active member of France 6G. France 6G is the national mission that is co-funded by France 2030's 65 million euros program. And we have participated with them in Mobile World Congress in March. We have been in different plenary meetings. The last one was in Paris in March. The next one will be at the end of May. And we will be at EU CNC in Malaga this June. Some people have already shared this, so this is a good opportunity to network. And to finish, well, this is just to give you an idea that we are embedded in the European 6G ecosystem and committed in the long term. So if you're working in microelectronics, RF systems, AI for wireless, or 6G infrastructure, I'll be very happy to connect after this session. Thank you very much. And this is all for me. Yeah.
Thank you very much for your presentation. Thank you again to all the speakers of the day and particularly the ones in the afternoon in the brokerage event now. With this, we conclude our brokerage event because we have reached the end of the presentations we have received and from the interested speakers. I believe that all the questions in the chat box have been answered. And if there is anything that you would like to hear from us of further details, you can always contact us via email. And we are going to upload today, the latest tomorrow, our presentations of the Info Day and the brokerage on our website. With many thanks to all the participants, all the speakers, for your time and your dedication to make this event a success. Thank you very much and have a nice day. Bye.
you.